Hello and welcome back to our YouTube channel Oracle DB Online Training. In this tutorial, we are going to explore about Oracle Transparent Data Encryption, which is also known as a TDE in short. And before I can proceed with the tutorial, I'd like to thank every one of you because we have recently achieved one milestone of 10,000 subscribers. And also, I would like to request all the users or members on the channels who would like to know the database courses from the scratch. Like if you are willing to learn the Oracle database program from the scratch, like you don't know anything in Oracle database, and if you want to start it, you can always enroll a membership program. And this membership program you can enroll by paying a very minimal amount of charges. And once you become a member on my channels, then you can definitely explore this course. It is almost 44 sessions which is started from the scratch, which has included various different topics like Linux operating system. Then you will be learning about Oracle database uh, core administrator, and then even though you will be learning backup recovery, you will be learning data guard, RAG patching, and OEM related topics that has been covered in the 44 session. Each of the session is almost like 2 hours, 1 hour basis. Depending on the size of the courses, you can learn these topics. Now coming back to the next section that I would like to inform you guys that if you want a ready course, you can always purchase a ready course from our channels. And for this purpose, you can visit our website. And if you visit our website, you'll definitely get the complete detail about it. Okay, so I'd like to show how you can purchase any courses from our website. You simply have to go to oracledbonlinetraining.com, and then once you reach this website, you can go to the get ready courses and VM machine. So from this, the latest course that we have published here is Oracle DB Ultimate for Advanced version. Okay, so this course has been designed with a lot of different topics from the basics to the advanced has been covered, and you can purchase this course. So coming back to today's agenda that we would like to have is about Oracle Transparent Data Encryption. Okay, so Oracle Database Transparent Data Encryption that we will be learning in today's session. So today's agenda will be, first of all, we'll be understanding how a TDE works, and then we'll be doing a practical session on the same. So let's first of all try to understand what is the meaning of transparent data encryption. So let's say we have one database, okay, and we wanted to have an intermediate security feature so that no other users who has access to the database can access the database. I mean, the data will be encrypted in a transparent manner. So the data will be published, or the users who can access the data who has a authority to see the data. Okay, so the here data get protected. So with the help of TD, we are basically protecting the data, and even though this data will be encrypted format. So let's say we have one database running, and this database backup has been stolen, or maybe some hacker has stole this backup, and now they will be restoring the database backup, and then they can get the detail about it. So let's say talk about if the database backup is encrypted. So in this situation, the users who is stealing the the hackers who has stolen the backups, they cannot see the data because it is encrypted format until unless they have a encrypted key. So the main benefit of using the TD is that it gives advanced security features, and also it protects the data. So nowadays, if you have any sensitive database, definitely you should use this advanced feature of Oracle, that is a Oracle Transparent Data Encryption. And the best benefit about this is that application level, there is no change required for the implementation of this transparent data encryption. Moving to the next section, what are the key components that we have in TD? So TD can be implemented using the column encryption, or we can also do the tablespace encryption. I'll give the more detail on these two topics, like how the column encryption will look like and what is the tablespace encryption will look like. Okay, and also the main terminology with respect to TD is key management, because if you encrypt something, you require a key. So to do the key management, we will require a wallet. Okay, so Oracle wallet for storing the master encryption keys are also required. And definitely when you are doing the data encryption, this encryption has to be done via the certain algorithms. So now we have a different algorithm that has been designed for Oracle TDE implementation. One is AES, and this can be done using the various bit methods. Like we can use 128, and which is a default one, then 192 or 256 bit. And also we can use another method with the encryption algorithm is 3DES, and this encryption method will be 168-bit data encryption. Okay. Now moving to the next section, what is the meaning of TD column level encryption? So TD column level encryption is basically it gives a column level encryption. So let's say we have a set of table which stores users details. Okay, and in this users details there is some sensitive information such as a social security number or maybe a credit card number. And this data, I mean, in general, if someone get this data, it can be a problem, right? So to avoid those kinds of situation, what we can do, we can do the column level encryption. So these numbers we can do the encryption format. So once we do the encryption, the data will be like in the encrypted format. So it will give the extra benefit, and it will protect the data. And the main advantage of column level encryption is that it has a less, or you can say minimal, performance impact. Okay, so this is one of the example how the TD at column level encryption works. Now the next section will be a tablespace level encryption. So if I talk about a tablespace level encryption, which means we have a, let's say we have a one Oracle database which has a various tablespace like the application space, tablespace, and we want to protect this data because it contains our actual application data. So here we don't look at specific columns. We are doing the entire tablespace level encryption. So any data which is part of this tablespace, they will be basically get protected. Okay, so here the using the tablespace level encryption is basically it includes all associated data files. So let's say in users tablespace we have 5 data files, so all the 5 data files has to be encrypted. And it also provides you the broader protection for all the data in the tablespace. Apart from this tablespace level encryption, key management is also important, and it has a slightly higher performance impact compared to the column level encryption. So when I say higher performance impact, which means it will require more CPU for data encryption, and it has basically slightly more overhead as compared to the column level encryption. Moving to the next section where we are talking about Oracle wallets. So Oracle wallets are very important for us to keep the keys, okay? Because when we implement TD, there's a key that we have to keep in the Oracle wallet. So to do the data storage, we can basically either keep the keys or the local file system, or we can keep this file into the a separate server, which is also known as a OKV server, Oracle Key Vault. Okay, so this external key management system is also basically known as a hardware level key management. And if you are using the local, then um, it's basically a software level, you can say, key management. Okay, and if you are, so now the next question will be, so while managing the Oracle wallets, you have to also ensure like a auto login functionality, because in today's session we are going to explore that as well, like how the auto login functionality works, like how the key management works. If we don't mention the auto login feature, if we don't implement it, so ultimately when the application when we start the database, your database will have have to open the, I mean, as a database administrator, we have to open the key for we have to open the wallet whenever we are starting the database. If it is in auto login mode, so we don't have to do any manual intervention in that case. And also a backup and recovery supports are basically handled if we have a TD, okay, means with Oracle Wallet feature has been implemented. So whenever we have to take the backups, I mean, uh, it will automatically refer the existing wallet key and backup will be progress. Okay, otherwise we have to always use what you call we have to always give the location for key management, and then we have to give the password for TD for management of any backups. We'll see how these things works, and as of now this is just a theoretical understanding. So once we will be moving ahead with the practical session, definitely we'll cover up everything related to the same. So overall, what are the benefit that we are getting by implementing TD for in database is that we are doing the compliances with the data protection regulation, and also a protection against unauthorized access to the data at rest. And also we are doing seamless integration with the existing application, and we can also use advanced key management options. Okay, what are the things that we have to consider while implementing TD? So the first one is a performance impact. Okay, because if you are using a column level encryption, the performance is less impacted. If you are using TDA at the table space level, the performance will be slightly more impacted as compared to the column. So the performance evaluation has to be done before we can proceed with a actual TD implementation. Apart from this, a plan for backup and recovery for Oracle Wallet. So whenever we are doing Oracle Wallet implementation, we have to ensure we have a backup, okay, and also we should have a recovery for Oracle Wallet if in case it get lost. So management of Oracle Wallet uh, using a backup and recovery mechanism has to be done regularly. Along with this, consider the integration with Oracle Key Vault. So basically, if we integrate it with Oracle Key Vault for enhanced key management, that will be always beneficial, because Oracle Key Vault is a separate system where we can keep our keys, and our database will be always in contact with OKV server. So whenever the data has to be fetched, it will authenticate from the OKV servers. Okay, and there are certain more features, or you can say review the compatibility. So we can also I mean, while working or implementing PD, we have to also see if we have a Oracle Data Guard already implemented and Oracle Golden Gate. So these additional tools also requires a key management. Okay, so we have to consider the Oracle's advanced features, such as Oracle Data Guard, Oracle Golden Gate, and so on. So the conclusion that we are making here is what is the benefit of TD, that TD offers robust encryption options for protecting the sensitive data at the rest. And also users can choose between the column level or a tablespace level encryption. In today's session, I will be doing a tablespace level encryption. And also Oracle Wallet provides a secure key management with the option of centralized management through the OKV server. So how the OKV server works and how we can implement OKV, we will be seeing in the next session, where I'll be showing you how that, first of all, how the installation of OKV works, and then we will be doing the configuration with the OKV server for any database TD implementation. Apart from this, we have a TD is a valuable tool for enhancing the data security, meeting the compliance requirements. Okay. So these are the things that we will be doing from the TD. Now coming back to practical session, we will be doing a TD implementation. So we have a step ready that we have to follow to do the TD implementation, and then we will be doing a tablespace level encryption. So now we'll proceed with a TD implementation. We have a database which is Let me see here. So we have started one database which is having a, sorry, I think there's some problem here. Let me start the database. I think the DB recovery file test location is having some issue. I need to check it out quickly. So what I'll do, will go to CDU01 app. Here we have a FRA location. Now we'll try back database startup command. We'll see how it goes. So we will be starting a database. So our database is almost started. And once the database started, the first thing what we will be doing, we will be taking a backup of P file. Okay, because it's a best practice to take a SV file backup in the form of P file before we can proceed with the rest of the steps. And also I would like to show you the database status first, like name and tables, some of the other details too. So let's execute the command select name, comma, open underscore mode, comma, from v dollar database. So this database is a prod database and it is currently running in the read write mode and it has a archive log mode enabled. Now the next step what we have to do, we need to take the SV file backup. So we have taken the backup of it and configure the key stored location. Okay, because this is very important step here. What we have to do, we need to create a directory structure. Okay, so first of all, we'll see what is the name of my database unique name. Okay, so unique name, we'll check the name of the database unique name is prod. And at this point, we have to configure key stored location. So you must configure key stored location and tab the setting wallet underscore root and TD configuration. So these are the two different parameters that we have to set at the database level. So before we can implement anything, let's do the quick check here. So parameter wallet underscore root. So this parameter is currently blank. If you're working on any 19C database, these are the two parameter settings that you have to make for TDE implementation. So as of now, these both the parameters are currently set to none. Okay, means it's a blank. And after that, and next step, we have to create a directory structure. So I'll exit from here and I'll cd to Oracle home admin. Here we will see whether the prod database location is there. Yes, it is there. And we have to go inside this directory. Here we need to create a directory structure. So the directory structure that we will be creating will be a wallet and TDE. Okay, so if we go to this location, now we have the location here. So this same location we need to mention here. Okay, which means, sorry, I think I did some mistake. We have to go to the Oracle base location. Let me recheck. So currently, yeah, we are at the base location only. Inside the base location, we have admin location. And inside this, we have a DB unique name. And then we have created a directory with wallet TD. Now again, I'll log in back into the database. After logging into the database, next step is that we need to set the parameter. So as we have seen, wallet root location was not set. So we need to set this parameter by running alter system set wallet underscore root, and then we have to give the location. So remember here, we are not giving the full path up to TD because by default, it will take the TD location automatically. We have to just give the location this one. After this, the next step is to restart the database. So we'll do the database restart and we'll see how this will look like. So now we have almost taken the database restart. So meanwhile, we'll also copy the next command that we have to check. So we need to check wallet root location. So we'll run show parameter wallet underscore root. So by running this command, we can see it's pointing to the correct location that we have created. After this, the next step is to check TD configuration. So now here the question will come, can we set both the parameter at one go? The answer is no, because until unless this parameter is set, you cannot set the next parameter. And in order to set this parameter, we will require a restart. Okay, so we have to do this step in this manner only. So here we have to set alter system set TD configuration key store configuration equal to file, because we are keeping our key under the file system. Okay, so we have to use configuration as a file. Otherwise, we can also use a HSM. HSM is basically a OKV based location. So since in our case, we are not using OKV based configuration, so we have to mention file option here. Okay, so this parameter also we have validated. Now the next part will be important one, like software key store. What is the meaning of software key store? Is that it is a actual key creation. Okay, so we will be first checking whether any wallets are configured on this database or no. So what I did here is I executed a command. Okay, so this command is select status from $encryption underscore wallet. So from this we can see the status is not available. Okay, and after that I executed a few more columns with respect to TD wallets. So what is the type? So type indicates file system, means we are using a local file system based configuration. This is the location of the TD wallet. Current status is not available. Container ID is 0, means is for the non-container based database. Okay. After this, the next step is to create the key. Okay. So this is the command administer key management key store, create key store, and then we have to give the path that we have created previously identified by the welcome mode. So whatever the password you want, you can keep password here. Yeah, so what I did, I just changed the password here just for our simplicity. I'll mention the this option as a administer key management key create key store, and this is a location of the file. So we have copied this command from here. I'll go back here. So before I do any execution, let's double check what are the file exist at this location. So as of now, nothing is there. Now we will execute this some command to create the new key store. Okay, so after executing the command, we will just double check what is here. So we can say we have a one e-wallet got e-wallet dot p12 file got created. Okay, so this file is basically a key store. So as we have executed the command administer key management create key store, and then this is the location for the key store that we have given, and this is the password that we have used to create the key store. Okay, so now the key store got created. After that, we will be again checking the status. So status, basically we will be first executing the status command. It says closed, means wallet is created but it is currently closed. Okay, and at this point the wallet type is file. This is the location, currently it is in closed state. After that, the next step will be auto login, because if you don't mention the auto login whenever you start the database, when you start the database, you have to manually open the wallet. Okay, so to do this, what we can do, we can create a auto login feature also. So here, what is the command to create the auto login? Administered key management create auto login, and then we have to use key store from existing key store, because it will refer the existing key store and then it will make a auto login for the same. So using this command, you will be creating the auto login feature. So as soon as you execute this command, we have to then recheck what are the files present at this location. So now we can see there are two files. So first was evalet that we have created. Now we have a cvalet.ss. So basically we have created auto login file with the help of existing file. Okay. So now cvalet is basically a auto login file that we have. After this, we will be also moving ahead with encryption details, like what are the existing status. Okay, sorry. So now we can see this is open no master key. Okay. So here previously it was in closed state. Now it is in the no master key found. So in order to open the key, we have to basically use this command, because as of now it says open no master key. So now we will be executing administer key management set key store open force, then key store identifier. So if for simplicity, we can keep the password same across all the command. Okay. So by executing this command, what we have done, we can double check now. Again, status says no master key. And finally, we will be running the command with set key store TDE encryption for master key. Okay. So here there is a slight change is happening, that we are making a force key store. So previously we are trying to open it. Now we will be doing a backup of this file. Okay. So let's execute this also. So by executing this command, we have completed with the open of the wallet. So previously it was saying open no master key. Now it has been opened by executing the command administer key manage set force key store identified by the password that we have used with backup option. So once this is completed, after that, the next step is to check the tablespace encryption that we have decided, because we wanted to do the tablespace encryption. So if you want to know which are the tablespace that are currently encrypted, you can use $encrypted underscore tablespace detail. And even though from $tablespace views also, we can refer some of the columns, like if you see here, we have a column called tablespace name from this view, and then other related information we can check it from the $encrypted underscore tablespace view. So we have multiple tablespace available here, and our target will be either app tablespace or users tablespace. So users tablespace, I think I have removed from this database, so we will be going ahead with app tablespace. So usually you will not be encrypting a system tablespace, temp tablespace, undo tablespace, and sysaux tablespace. So we'll be only doing the encryption of any tablespace which is related to the application user. So in this case, let's say I want to encrypt the apps tablespace. Okay. So I'll copy the apps tablespace from here, and then I'll mention it here. So there are two options available now we have. So if you want, you can do the online encryption, or you can do a offline encryption as well. Both the options are available. Okay. So in order to do the online encryption, we can use this column, a command, alter tablespace name encryption online, using whatever the algorithm that we want to do for encryption, and then we need to mention encrypt. So this command will encrypt the tablespace, apps tablespace. Okay, so let's do this one. So while this encryption is progressing, we can also see the database alert log. So in the database alert log, we can see these are some of the data file which got encrypted. Okay. And what is the meaning of encryption is that if you try to read the data file content, it will show the commented data. Okay, let's do this way. So suppose some user got access to the table space. Okay. So usually if this kind of data is, if the table space is encrypted, this is how the data will look like. Okay, means user will not be able to access the data. Okay, if in normal table space is there, at least some data will be visible. So it is always advisable that we should encrypt the table space. And also again, we will be re-executing this command to check if the table space got encrypted. So here we can see the app tablespace got encrypted with this encryption algorithm. Apart from this, we can also see status by running the db underscore tablespace view, because in this view we have an encrypted column which says yes, means tablespace is encrypted. Let's say if you are creating a new tablespace and you want to do the tablespace encryption, so you can execute this command, create tablespace name, and then you have to mention the data file location, size, and at the end you have to mention encryption using algorithm, and then you have to give the default storage clause. So this way also we can do the tablespace encryption. Apart from this, if you want to do the tablespace encryption offline, so to do the offline encryption, you have to use alter tablespace name offline. For example, in our case, let's say we are talking about user table app tablespace. So I'll copy this tablespace name here and here also. Okay, so first of all, we have to make this tablespace offline, and then I'll mention uh, alter tablespace app encryption offline using the algorithm name and then encrypt. At the end, we have to make this tablespace online again. So this can be done using this. And at the end, we can validate using the above commands. So this is how we can do the tablespace encryption. Okay. Now the next question will be how we can decrypt this tablespace. So let's say there's a requirement comes that you have to decrypt the tablespace. So in order to do the data tablespace decryption, you have to use this command. There are two ways you can do, either online or you can do offline. So if you want to do online, you have to execute this command, alter tablespace name, decrypt. Okay, so let's say I'm talking about app tablespace here. I can simply do this way. Alter tablespace name, encryption online, decrypt. Okay, so this way what will happen, this tablespace will become decrypted. Okay, and if I want to do this tablespace decryption offline mode, so simply we have to first take this tablespace offline, and then we need to run alter tablespace name encryption offline, and at the end we need to mention decrypt. Okay, so here we are previously mentioned encrypt, and here it is just slightly opposite like decrypt. And then you can revalidate the tablespace status by running this command. And also there are some commands that we can check to validate the status of wallet. So we can always run do ls-lrth of this tablespace. These are the files that is present at this moment. And also we can check what are the keys available for this. So while executing this command mkstore wrl and then a wallet location -list, you have to put the password that you have used. So let's say I'm used this password while creating the wallet, so I need to mention it here. So from this command execution, we can see that we have a store entries, like these are the different store entries that is present. Okay, so this is how we have to do the data tablespace encryption. If and also we have seen how to implement the TD. Okay, for any database which does not have any TD feature implemented. The only thing is that once you implement the TD, you cannot remove the TD feature. Okay, because you can encrypt and decrypt the tablespace, but you cannot remove the feature completely from the database. So it's a one-time process. If you execute it, I mean, it will remain forever. So while implementing it, just double think and take the decision accordingly. So I hope you have understood how to implement the TD in any database. And if you feel that you need any question, you have any questions, you can write on in the comment section. I'll definitely try to answer those questions. Also, I'll request, if you are interested about our courses, please do enroll from our website. If you are looking for any YouTube related documentation, you can please purchase this from my website. It will hardly cost you anything. So please do support us and purchase the courses from here. If you are a new or on our channel, please do subscribe. I can still see there 80% of our users are non-subscribe users. So please do subscribe and support, and keep learning from our channels and take the membership program if you are interested in. And once again, thank you for watching our tutorials. Please follow us on various social media platforms. Have a nice day. Thank you.